All right, everyone, get ready for a deep dive. We're taking a close look at some seriously fascinating AI research today. Self-driving cars, they're always in the news, and this paper from Apple called Robust Autonomy Emerges from Self-Play is really making some big waves.
Yeah, it's pushing the boundaries of what we thought was possible in the world of autonomous driving, that's for sure.
And here's the thing that really blows my mind. This AI can drive with incredible skill, and it's never even seen a human driver before.
It's true, no human driving data was used at all. This AI learned everything through self-play in a simulated environment.
And we're not just talking about a quick spin around the block in a simulator either. This AI has racked up the equivalent of driving from, get this, the sun to Saturn.
Can you believe that? It's something like 9,500 years of driving experience crammed into this one AI. Just incredible.
So how does an AI become such a skilled driver just by playing against itself?
Well, it all starts with their secret weapon, and that's what they call Gigaflow. You can think of Gigaflow as like a high-tech driving school, but specifically designed for AI, using a technique called self-play reinforcement learning.
And this simulator is incredibly fast, right?
Yeah.
And we're talking about simulating 42 years of driving experience, but it takes only 1 hour on a computer with 8 GPUs.
Exactly.
And it can handle some pretty complex situations too, right? Like it can simulate a bustling city, maybe even with like 150 cars, trucks, cyclists, maybe even pedestrians all interacting with each other, and Gigaflow can handle all that.
Yep, Gigaflow is up to the task.
Wow.
And here's the kicker. It's super efficient too. They can simulate 1,000,000 kilometers for less than $5.
$5, that's less than I pay for a gallon of gas.
It really puts it into perspective, doesn't it? But the real magic here is how they've set up the self-play within Gigaflow. They use a single AI model, a parameterized policy, to control all the different agents in the simulation.
So that means you've got one AI brain learning from the experiences of hundreds of different virtual drivers.
That's right. And because each of those virtual drivers has their own style and way of behaving, it creates a really diverse and challenging environment for the AI to learn from.
Gotcha. And the diversity is really the key here, isn't it? I mean, it's not about learning to drive perfectly in one specific scenario. It's about learning to handle unexpected situations and all those different driving styles that you find out on the road.
Absolutely. The AI needs to learn how to adapt and navigate a world where not everyone is following the rules perfectly, just like in real life.
So it's basically like learning to drive in the real world, but without the risk, right?
Yeah, that's a good way to put it. And the results are impressive, to say the least. This AI trained purely through self-play. They put it up against other AIs that were trained on those massive data sets of human driving data, and it just blew the competition away.
No kidding. So it's not just keeping up. This AI is setting a whole new standard.
Exactly. They tested it using 3 different industry standard benchmarks: Correlate, NewPlan, and the Waymo Open Motion dataset.
And it outperformed AI specifically designed for each benchmark.
Yeah, even the AI specialized for a single benchmark couldn't keep up with it.
So walk me through those benchmarks. What are those? What's the difference?
Okay, so you've got SARLA, which tests the AI on longer driving routes and those really complex pre-planned scenarios. Then you have NewPlan, which uses real-world data, so it's evaluating how well the AI can handle those everyday driving situations.
Right.
And finally, there's the Waymo Open Motion dataset. This one focuses on how the AI interacts with human drivers in a more, realistic environment. It's a tough test for sure.
Sounds like it. So it's basically like an AI driving Olympics, and our self-taught AI champ is taking home the gold in every single event.
I like that analogy. That's a good way to put it. And the truly impressive part is that it can take what it's learned and apply it to all sorts of different situations. It adapted flawlessly to different types of vehicles, different maps, even different scoring systems across these different benchmarks.
Wow. So it's not just learning a set of rules, like by rote or anything like that. It's learning something much deeper, something more fundamental about the principles of driving. It can adapt to new environments and challenges.
Yeah, exactly. It's showcasing a level of flexibility and adaptability that we really haven't seen before in autonomous driving AI.
That's amazing. So how does it work? What's going on under the hood? How is it making those split-second decisions? You're navigating these complex environments with such amazing skill.
Well, to understand that, the researchers had to dig into the AI's neural networks,
Right?
specifically the policy and value networks, to figure out, how it makes decisions.
Right. So can you remind me what those are again?
Of course. So imagine the policy network as the AI's driver's ed manual. It's basically the part of the AI that decides what action to take in any given situation,
Yeah.
whether to speed up, brake, change lanes, all that jazz.
So it's like the AI's brain deciding what to do, which pedal to push,
Mhm.
so to speak.
Exactly. And then you have the value network, which is more like the AI's inner GPS system. It helps the AI figure out which of those actions is likely to lead to the best possible outcome, which means reaching the destination safely and efficiently.
Ah, I see. So it's not just about making any old move. It's about making the right move, the smart move.
Precisely. And one of the coolest things they discovered is how this AI uses something called attention.
Attention, like how I'm trying my best to focus on this conversation right now, yet not get distracted by, my phone.
Haha, exactly like that. Our brains can only process so much information at once, and this AI has actually learned to zero in on the most important pieces of information in any given moment, just like we do.
So it's filtering out the noise, the distractions, and focusing on the things that really matter for driving safely.
Exactly, and it's doing it remarkably well.
So can you give me an example? Like, how does this attention thing play out in a real driving scenario?
Sure, so picture this. The AI is approaching a busy intersection. It's not just looking at everything in its field of view.
Right.
Instead, it's laser focused on the cars around it, their speed, what direction they're heading in, whether or not they're signaling, all the important cues.
So it's like it's reading the behavior of those other drivers to kind of predict what they might do next.
Exactly, much like a human driver would.
That's pretty impressive.
And there's more. Get this, it can even plan for events way down the road. The researchers found that the AI was reacting to obstacles up to 150 meters away.
Whoa, 150 meters. That's like a whole city block. It's really thinking ahead, not just reacting to what's right in front of it.
Exactly. That level of foresight is just remarkable.
It really is.
And here's another fascinating detail. They found that the AI's driving style actually changes depending on what type of vehicle it's controlling.
Oh, really? So you mean it drives differently if it's, say, a sporty little car versus a giant lumbering truck?
Exactly. It adjusts its behavior based on the vehicle size, its capabilities, and even its goals. If it's in a big truck, it will be more cautious, it will take wider turns. But if it's behind the wheel of a nimble sports car and it needs to get somewhere fast, it might be a little bit more, let's say, spirited in its driving.
So it's not just a one-size-fits-all kind of driver. It's like having a whole team of AI drivers, each one specialized for a certain type of vehicle.
That's a great way to put it. It's truly impressive how adaptable this AI is.
That's really fascinating stuff. So what are the bigger implications of this research? Beyond just autonomous driving, what else could this self-play approach be used for?
Well, imagine using this technology to create ultra-realistic traffic simulators.
That would be a game changer. I mean, think about the possibilities for city planners, traffic engineers.
Absolutely. They could use these simulations to test out all sorts of different traffic flow solutions. They could experiment with new road designs before, actually going through the hassle and expense of implementing them in the real world.
It's like a virtual testing ground. And if you think about it, they could even use it to design safer roads. I mean, you could simulate all kinds of different scenarios and potential hazards.
Exactly. You could potentially identify those problem spots before they even become real-world issues. And it goes way beyond just driving. This self-play approach could revolutionize robotics, for example.
How so?
Imagine training robots to perform those super complex tasks in really challenging environments, things like search and rescue operations,
Wow.
or even exploring other planets, all without any human involvement.
That's mind-blowing.
Yeah, and let's not forget the entertainment industry. This technology could transform the way we experience video games. Imagine games populated with characters that are so lifelike and intelligent.
Oh, wow. Yeah. Characters that learn and adapt to your every move. It would make the gaming experience so much more immersive and challenging.
Exactly. And think about the implications for scientific research. You could train AIs to analyze massive data sets, run simulations, even design experiments, significantly speeding up the pace of scientific discovery.
The possibilities are truly endless. It's like we've unlocked a new tool, a new way of approaching AI and how we use it to solve problems and push the boundaries of what's possible.
I completely agree. It's a really exciting time to be working in this field.
And one of the most exciting things to me is that this approach could potentially make AI development less expensive and complex.
It definitely has the potential to do that.
I mean, I know that traditional AI training requires tons of label data. And that can be really expensive and time-consuming to collect.
It's a huge bottleneck in the field, that's for sure. But with self-play, the AI essentially generates its own training data.
Through its interactions within the simulated environment.
Exactly. It's a much more efficient and scalable approach.
So it's almost like a child learning by playing, just figuring things out on their own.
Yes, exactly. And it opens up a whole new world of possibilities for training AI for those tasks where you either don't have enough real-world data or maybe it's just impossible to obtain.
That's incredible. This is really some mind-blowing stuff, but before we get carried away with all the amazing possibilities, I think it's important to acknowledge that there are still some challenges that we need to tackle.
Of course, like with any emerging technology, there are limitations and potential risks that we need to carefully consider.
Like what? What are some of those potential downsides that we need to be aware of?
Well, one thing to keep in mind is that simulations, no matter how realistic we make them, are never perfect.
Right.
They just can't fully capture the incredible complexity and unpredictability of the real world.
So what you're saying is that an AI that can drive perfectly in a simulation might still run into trouble when it's out there in the real world where you have unexpected situations popping up all the time.
Exactly. There's a real risk that the AI might over-rely on those patterns that it learned in the simulation and not be able to adapt to all the nuances of the real world.
That makes sense.
So there's a lot of work that still needs to be done to make sure that these self-taught AIs can safely and reliably navigate the real world.
Absolutely. This is all incredibly promising, but it's clear that there's still a long road ahead.
Absolutely. There's a lot more research and development to be done, but the potential is truly exciting.
It really is. So I'm curious, what are some of the other potential risks or downsides of this self-play approach? Are there any things that we haven't touched on yet that we should be thinking about?
Well, one concern is that the AI might develop behaviors that we didn't anticipate.
Oh.
When you let an AI learn entirely on its own, there's a chance it could come up with strategies or solutions that we never even considered. And those might not always align with, our goals or values.
I see what you mean. So it's like the AI might find a loophole in the system, a shortcut to achieving its goals, but it might not be the kind of shortcut that we would want it to take.
Exactly. AI systems are ultimately designed to optimize for a certain objective, but if that objective isn't perfectly aligned with our desired outcome, or if the AI finds a way to achieve that objective that we didn't intend, it could lead to some unexpected and potentially undesirable results.
That's a really good point. So it's not just about creating a realistic simulation. It's also about carefully defining those goals for the AI, making sure that they are aligned with what we actually want to achieve.
Absolutely. And we need to be really careful about monitoring the AI's behavior during those training and testing phases to catch any potential problems early on.
Right. So it's kind of like teaching a child to ride a bike.
Yeah.
You want to give them the freedom to learn and explore, but you also have to keep a close eye on them. Make sure that they don't veer off course or crash into something.
That's a perfect analogy. It's about finding that balance between giving the AI the freedom to learn and making sure that it stays on track.
So we need to build in some safeguards, some mechanisms for intervention,
All right.
just in case the AI starts exhibiting behaviors that we don't want to see.
Exactly.
This whole conversation has been incredibly thought-provoking. We've covered so much ground today, from the nuts and bolts of self-play and gigaflow to those broader implications for AI development and all the potential risks. But is there anything else that you think our listeners should keep in mind as they're processing all of this information?
I think the most important thing to remember is that this research is just the beginning.
Okay.
It's a really exciting glimpse into the future of AI, a future where AI can learn and adapt in ways that we never thought possible. But it's also a reminder that we need to be thoughtful and responsible in how we develop and use these incredibly powerful technologies.
Absolutely. It's that old saying, with great power comes great responsibility.
Exactly. As we keep pushing the boundaries of AI, we have to prioritize ethical considerations, safety, transparency, to ensure that these technologies are used for good, that they benefit all of humanity.
I love that. That's a perfect note to end on. This has been an amazing deep dive. I think we all have a much deeper understanding of the potential of self-play in AI, but also the challenges that we need to address.
I agree. It's been a great discussion. Thanks for having me.
A huge thanks to you, our expert, for walking us through this complex and fascinating topic. And of course, a special shout out to all of you, our amazing listeners, for joining us on this journey of discovery. We hope you found it as insightful and thought-provoking as we did. Until next time, Keep exploring, keep learning, and keep asking those big questions.
I couldn't have said it better myself.
Yeah.
Yeah, it really makes you wonder, how this AI is actually making those split-second decisions out there on the virtual road, navigating those complex environments with such incredible skill.
I know, right? It's mind-boggling. What's going on under the hood? How is it processing all that information and making those smart driving choices?
Well, the researchers actually dug into the AI's neural networks, specifically what are called the policy and value networks. They really wanted to understand its decision-making process.
Okay, that's right. The policy and value networks. But remind me again what those are exactly.
Sure. So think of the policy network as like the AI's driver's ed manual. It's the part of the AI that figures out what action to take in any given situation, like whether to speed up, hit the brakes, change lanes, you name it.
Okay, so it's basically like the AI's brain deciding which pedal to push or
Yeah.
which way to turn the wheel.
Exactly. And then you have the value network, which is kind of like the AI's internal GPS system.
Okay, I'm following.
This network helps the AI figure out which of those actions are likely to lead to the best possible outcome, like reaching the destination safely and efficiently.
Ah, got it. So it's not just about making any move, it's about making the smartest move, the one that helps it reach its goal.
Precisely. And one of the most fascinating things they discovered is how this AI uses something called attention.
Potential. Okay, so like how I'm trying to focus on our conversation right now and not get totally distracted by, all the other things going on around me.
Exactly. Just like our brains can only process so much information at once, this AI has learned to focus on the most crucial information in any given moment.
So it's basically filtering out the noise and zeroing in on the stuff that really matters for safe driving.
Exactly. It's incredibly efficient that way.
Can you give me an example? Like, how does this attention thing work in a real driving scenario?
Sure. Let's say our AI is cruising towards a busy intersection. Now it's not just looking at everything in its field of view all at once.
Right.
Instead, it's paying very close attention to the cars around it, their speed, the direction they're going, whether they're signaling, all those crucial details.
So it's like it's reading the behavior of other drivers to kind of anticipate what they might do next, just like a human driver would do.
Exactly. It's learning to predict and react to the actions of others. And get this, it can even plan for events that are way down the road.
Oh, wow, really?
Yeah, the researchers found that it was reacting to obstacles that were a whopping 150 meters away.
150 meters, that's like a whole city block. So it's not just reacting to what's right in front of it. It's actually thinking way ahead.
I know, it's pretty amazing, right? It's like it has this incredible foresight, which is crucial for safe driving. And here's another really cool thing they found. The AI's driving style actually changes based on the type of vehicle it's controlling.
Wait, really? So you're telling me it drives differently if it's say, a zippy little sports car compared to like a big lumbering truck?
Exactly. It adapts its driving based on the size and capabilities of the vehicle and even its goals. Like, if it's in a big truck, it's going to be more cautious and take those wider turns.
Hmm.
But if it's in a nimble sports car and needs to get somewhere quickly, it might be a little bit more, shall we say, spirited in its driving.
So it's not just a one-size-fits-all driver. It's more like having a whole team of specialized AI drivers, each one with its own unique skill set.
That's a great way to put it. It's incredibly adaptable and versatile. This research is really opening up a whole new world of possibilities, not just for autonomous driving, but for other fields as well.
Okay, so now I'm really intrigued. Let's talk about those possibilities. What else could this self-play approach be used for?
Well, for starters, just imagine using this kind of technology to create hyper-realistic traffic simulators.
Oh yeah, that would be a game changer for sure.
Yeah.
I mean, think about it. City planners and traffic engineers could use these simulations to, really test out all sorts of different traffic solutions or experiment with new road designs in a safe virtual environment.
Exactly, before they actually go through the trouble and expense of implementing those changes in the real world. And they could even use it to design safer roads, by simulating all kinds of different scenarios, identifying potential hazards, and really try to make our roads as safe as possible.
It's like having a virtual testing ground for all things transportation. And thinking beyond just driving, what about applications in other fields like robotics?
Oh, absolutely. This self-play approach could really be transformative for robotics. Imagine training robots to perform incredibly complex tasks. Those really challenging jobs, like search and rescue operations in disaster zones, or even exploring other planets. And all of this without any human intervention.
Wow. Okay, so we're talking about robots that can learn and adapt on their own in those super dangerous or unpredictable environments. That's incredible.
I know, right? And don't forget about the entertainment industry. This technology could revolutionize video games. Imagine games populated with characters that are so realistic and intelligent that it's like they're actually alive.
Yeah, I can see it now. Characters that learn and evolve as you play, making the game much more immersive and challenging.
Exactly. And let's not forget about the impact on scientific research. We could train AI to analyze those massive complex data sets, run incredibly detailed simulations, and even design new experiments, potentially accelerating the pace of scientific discovery.
The possibilities seem endless. It's like we've unlocked this new tool, a new way of thinking about AI and how we can use it to solve problems and, just push the boundaries of what's possible.
It's an incredibly exciting time to be working in this field, that's for sure. And one of the most exciting things to me is the potential for this approach to actually reduce the cost and complexity of AI development.
Okay, how so?
Well, traditional AI training often requires these massive data sets of labeled data, which can be incredibly expensive and time-consuming to collect.
Yeah, it's a huge undertaking to gather and label all that data. It's one of the major bottlenecks in AI development, for sure.
Exactly. But with self-play, the AI is essentially creating its own training data through all those interactions in the simulated environment.
So it's like learning by doing, just like a kid playing in a sandbox, figuring things out for themselves.
It's a much more efficient and scalable approach. And this opens up so many possibilities for training AI for tasks where real-world data is either scarce or too dangerous or expensive to collect.
That's absolutely fascinating. So this is really mind-blowing stuff, but before we get totally carried away with all the incredible possibilities, I think it's important to acknowledge that there are still some hurdles that we need to overcome, some challenges we need to address.
You're absolutely right. As with any new technology, we have to proceed with caution and a healthy dose of realism.
Yeah, I think that's a really important point. We tend to get excited about all the cool stuff that AI can do,
Uh,
but we can't forget about those real-world complexities.
exactly. The real world throws curveballs that no simulation can fully anticipate.
Absolutely. So I'm curious, are there any other potential downsides or risks to this self-play approach that we haven't talked about yet? Things we really need to be thinking about as we move forward with this technology.
One thing that comes to mind is the possibility of the AI developing behaviors that we didn't expect, things that could catch us off guard.
Oh, okay, so like unexpected consequences.
Yeah, exactly.
Yeah,
When you let an AI learn entirely on its own, there's always a chance it might stumble upon strategies or solutions that we didn't anticipate, things that might not align with our goals or our values.
so like it's finding a loophole in the system, a shortcut to achieving its objective, but it might not be the kind of shortcut that we would want it to take.
Yeah, that's a good way to put it. Remember, these AI systems are ultimately designed to optimize for a specific objective, the one that we give them. But if that objective isn't perfectly aligned with our desired outcome, or if the AI finds a way to achieve it in a way that we didn't intend, well, things could get a little messy.
Right, could lead to some unpredictable, maybe even undesirable results.
Eh,
So I guess it's not just about creating a realistic simulation. It's also about carefully defining those goals for the AI and making absolutely sure that those goals are in sync with what we want to achieve.
You got it. We need to be really vigilant about monitoring the AI's behavior as it's learning and as we test it, to catch any potential problems before they get out of hand.
It's like teaching a child to ride a bike.
Right.
You want to give them the freedom to learn and explore, but you got to keep a watchful eye out, make sure they don't go careening off into a ditch.
I like that analogy. It's a good one. It's about finding that balance between giving the AI the freedom to learn and explore, to reach its full potential, but also making sure it stays on the right track.
Right, so we need to build in some safeguards, some mechanisms to intervene if the AI starts to exhibit behaviors that we don't want to see.
Absolutely. Safety and control are paramount, especially when we're talking about powerful technologies like this.
This whole conversation has been absolutely fascinating. We've covered so much, from the technical details of self-play and Bigaflow to the broader implications for the future of AI and all those potential risks we need to be mindful of. But before we wrap things up, is there anything else you'd like to add, something you think our listeners should keep in mind as they digest all this amazing information?
I think it's crucial to remember that this research is just the tip of the iceberg, It's a glimpse into a future where AI can learn and adapt in ways we never dreamed possible. But it's also a powerful reminder that we need to be thoughtful, responsible stewards of these incredibly powerful technologies.
With great power comes great responsibility.
Exactly. As we continue to push the boundaries of AI, we need to make ethics, safety, and transparency top priorities. We have to make sure that these incredible advancements benefit all of humanity, not just a select few.
I love that. That's a perfect note to end on. This has been an incredible deep dive, and I think we've all come away with a deeper understanding of the potential of self-play and AI.
It's been my pleasure.
A huge thank you to you, our expert, for guiding us through this complex and fascinating topic, and a special shout out to all of you, our amazing listeners, for joining us on this journey of discovery. We hope you found it as insightful and thought-provoking as we did. Until next time, keep exploring, keep learning, and never stop asking those big questions.